here, but it will try to come close to that model, or it will try to resemble this model in the particular behavior we're interested in. So this is the process of system identification. Let's take a look at the next picture, which is the same but with control. So in control, again, we have this first important part, which is the system or our plant. Here we see something like a satellite dish or anything that you want to control. And let's say you want to control its angle. So we need some kind of sensor to measure its angle. What is the sensor? Are you familiar with this sensor? No? I think it's some kind of capacitor. Is that right? You should know more than I do, because, as I said, this is not... Okay, let's look at the next picture. So we still have the output, and the output goes to the sensor, but and then the sensor, so Y is usually used as a convention that we use for the output, and we need it to go into the computer for system identification. And also we need the input, as we said in the previous slide. We need the input and output. The input is given by some sort of input source, actuator, but things are not always as good as we expect them to be. So there may be an error that goes into the system which we do not know. So what goes into the computer is your input, but what actually goes into the system is the input plus an error. Let's see. So with these input and output, we can do system identification, and also we have to consider the disturbance estimation, which is also error analysis. Then what's added to this slide is the control. For control, we have many methods, including pole placement, optimal control, and predictive control. These are all the topics that will be covered in this course, so I will not elaborate on that. And using any one of these control methods, you send a signal out to your actuator. And actuator is what actually gives the input to the system. Okay, so that's the introduction to control course. In this class, Dr. Zhuang will cover examples, techniques, and examples. And by modern control technique, we mean focusing on some state-space methods. If you are a student of this engineering science department, you probably have taken at least one course related to control already. And the usual standard classical control usually focuses on frequency domain methods. And in this course, we will also, let's see. Well, you can read off the slide, but basic mathematics will be reviewed today. And there are many subtopics of control, including passive and active control, adaptive real-time control. You'll see a more detailed syllabus later. And we also give examples that are more focused on, so examples have a very broad range and control is everywhere. But by that I mean in electric circuits you can see control. In aviation you see control, or in blah blah blah, maybe economics or something, you see control. But we focus on vibrational problems and acoustic noise reduction. And then this is the agenda for each week. I'll just read through these topics. The first week was supposed to be the introduction, which I'm doing now, but I'm going to add to this week the discussion on ordinary differential equations. In the next week you will see some advanced control techniques, I suppose with some examples. And then in weeks 3 to 5, more on fundamental matrix algebra and some more math. And then we also need modeling techniques. It's also a basis. We need to have the mathematical model. So in other words, the theoretical model first to start our knowledge on this control. Then response of dynamic systems. I'm not sure exactly what that will be, but you will know. And then you have your first midterm. Then a sequence of different types of controls will be discussed in the second part of this course, including passive control, state-space model, as I said, will be the emphasis, and feedback control, dynamic feedback control, optimal control, predictive control. Okay. The textbook for this course are the same textbook for system identification. What I have to comment about this textbook, you see these are the covers of the two textbooks. Both are written by Zhenan Zhang and co-author. The first book is Applied System Identification, that is a part of control. And the second book is written in 2000 something. First book was written in 1994. And the second book is co-authored with this guy who is a longtime collaborator with Dr. Zhang.